Hey everybody, I wanted to take a moment and record a video for you. I have fielded several questions on the Discord server about basic, whoops, can't even see me, can you? Basic network security and some stuff that you might not know how to start. So for some of you, this is going to be very basic information. If you already know how to find and map your network, then this video is not for you. If you do not know how to find and map your own network, then this video is totally for you and you should try some of these things out at home. I'm going to say my standard caveat as I would with any of my other students. And that is, if you do not have permission to do this on the network you are attached to, do not do it. In some cases, you're going to definitely violate some ethics and some moral boundaries. Other cases, you may be violating state and federal law. So make sure that you have permission to do these things on both the device and the network you're going to be doing them on. With that being said, I own my own network up to a point, and then I own the devices that I'm going to be doing this on. So I'm free and clear under the Computer Fraud and Abuse Act of 1986. Make sure that you are too. All right. So out of the first questions that I've gotten through private messages is, how do I start? How do I learn about networking? This video again is designed for the novice, somebody who's just starting out, and that's fine. Everybody started out some way. I started out learning the same stuff just a very long time ago, and it's fine to do that. So with that in mind, the easiest thing to do is to map your own network. Do this in addition to whatever study guide you might be working on. If you're working on one, something like a CCNA, or you're trying to figure out a Network Plus certification from CompTIA, this video will help along that line. Easiest thing to start with is your own computer, the machine that I'm recording this video on right now. And so what I'm going to do is I'm going to swing my command prompt over here. It's a basic Windows 10 command prompt. Nothing special here. And you're like, well, Chris, what if I'm on Linux? Don't worry, I'm going to show you that too. I have a Raspberry Pi all fired up ready for you. So the first thing I'm going to do is I'm going to find out about what my computer is. I'm going to, aside from a computer on the network, I'm going to type in ipconfig. That's ipconfig. And it's going to give me some basic information. Like, these are all the adapters I have on this. This is the basic IP address. If there's a subnet mask or a default gateway. And you're like, well, that's not much information. Actually, it's quite a bit of information. It's a great start. We're going to take a look at the one down here, the wireless LAN adapter Wi-Fi. I have several adapters on here because I have several virtual machines on this computer. So sitting next to me is my computer. It's right here and down. And on that, I have a antenna attached to a USB device that gives me Wi-Fi. The IP address of this computer is 10.0.1.195, and that is an address I gave it on the router. The default gateway, this is the way to think about a gateway is this is a gateway to a bigger world. It's the portal to something that's not local. So my gateway goes out to the cable modem, which goes out to the internet, in which case both my router and the cable modem or the fiber modem are functioning as gateways. My default gateway is 10.0.1.1. I gave it that address, so that's the subnet that I chose to give it to. The 10.anything and 192.anything are reserved for private use only. That you do not find those addresses out there in the world. With that being said, let's move on. So that's a lot of information, but not specific information. So I'm going to type in ipconfig/all. Let's go to that wireless LAN adapter. You can see that it's done for the other adapters as well. You can scroll up and see all the adapters you might have connected to it. And if I were physically connected beyond the Wi-Fi, I would have IP addresses in there as well. So you can see it's a TP-Link wireless USB adapter, and I'll highlight it here for you. The physical address is the hexadecimal code for the address of the device itself. It is a dynamic address, so DHCP is enabled, which means that the router gives me the address at random. However, I have told it on the router side, in my little wireless router, that I would like to have this address And that's why you see the word preferred here under the IPv4. Now, what I will not go into right now is the difference between IPv4 and IPv6. So when people talk about your IP address, please understand that they are specifically talking about an IP version 4. If they're talking about an IP version 6, they'll say so. It'll be said as much. The lease was obtained Friday, June 25th, 2021 at 4:04 a.m. That's the last time I rebooted, which was, 4 days ago. The lease expires tomorrow, and it'll ask for a new DHCP address, and the router is going to give it the exact same address. The default gateway, think of this as your router, is 10.0.1.1. The DHCP server, so I have devices that do connect that I don't reserve addresses for. Things like my iPhone or my Android tablets, my wife's phone, anybody who comes in who has access to my network. They all get dynamic addresses. I don't reserve them. They get what they get. Okay, so and the DNS servers. DNS is domain name server. It's used for a protocol called domain name resolution. And computers don't understand google.com, but they do understand IPv4. So when you type in go to google.com, the computer goes, I don't know what that means. DNS, tell me what this means. And it says, hey, come back and we'll go. So just to show you how that works, we'll type in google.com, and you can see the current address that it comes up. The ones closest to me that answered the fastest was 142.250.190.110. That's what a DNS server does. So the fact that I have a DNS server in the same network address range as my gateway that I assigned it means I'm running my own DNS server. I do this for a service called Pi-hole on a Raspberry Pi. It does a great job of blocking ads and server-side ad requests, so I don't have to watch them. And so that's why I run my own DNS. If it's not something that is blocked, it forwards on to 10.0.1.1, which then forwards on to the Google servers of 8.8.8.4 and 8.8.8.8. I've typed this in way too many times. Okay, so this is a huge amount of information. So I have the MAC address, the machine address code of the physical hardware. That's 98.48.27 3 Bravo Delta 821. And I have the IP address as well as what gateway and client it connects to. You're like, well, that's great. Now I know one computer, but I want to know everything on my network. Well, we can find that out by typing in APR. So let's do it right. ARP-A. This stands for the Address Resolution Protocol, and -A says tell me everything. About every 60 seconds, every device on the network goes, hey, who's out there? And ARP responses on the network stack say, I'm out here, here's my IP address, here's my machine address code. So my physical code on the network and my IP address on the network. So if I type in ARP-A, I'm going to make this a little bit bigger for you. You can see that it'll come back with everything in every subnet and every network that I have access to. The 192.168.58.1, that is controlled by AT&T. I have any control over their addresses. I don't have any control over the 224.0.0 range or the 239 range. Those are all networks controlled by AT&T that I can see. The ranges I control and have access to are the 10.0 range, so 10.01.1, 10.0.1.34, 10.0.1.255. Those are the ones that I have access to. And right now, with the exception of probably my phone, everything that I have on the network is currently on, because I believe I shut down my other Linux box temporarily. So there was a .139, a 10.0.1.139, and that is not showing up right now because I believe it is powered down. So this tells you kind of what the address is, whether it's a dynamic address or whether it's a static address. Does it change on a reboot? You know, that kind of thing. This is an excellent way to start mapping out your network and start making a list. What connects to what? They're like, okay, this is great. This gives me a pretty good indication of what's available on my network. How do I do this in Linux? Well, let me just bring this right on over. As you see, I'm an SSH'd into my Research Pi. It's a Raspberry Pi I use for statistical packages. And you can see that the last login was from this computer was 10.0.1.195. Now in Linux, it's not IP config, it's IF config. That is Indigo Foxtrot config. And it'll show you again all the addresses I have available to me. With here, I've got a Docker address because I'm running some Docker stuff on this, and then I have the actual Ethernet cable that I have plugged in, and then it's always going to show you what is called an LO or a loopback address. And the loopback address is the address internal. The way Unix and Linux work is it'll tell you what that is. That's always going to be either localhost or it's going to say 127.0.0.1, which is also known as home. If you've never seen the little doormats, it says there's no place like 127.0.0.1. That means there's no place like home. Okay, with this, I can say, all right, what do I have available to me? This is exactly how you get all the hardware stuff here. You can type in ARP here as well, and it'll do the same exact thing. It'll tell you everything on the network. And it looks like this one's pulling a little bit better because this one's pulling the phones and tablet devices I have in my house, as well as my Nest. So you can see that I have one phone plugged in. I have a laptop live, or at least it was. My wife's laptop is live. My RT, my router, is live. This computer, which is Logan 6, is live. And if you don't understand Logan 6, then watch the old movie Logan's Run and you'll get it. My wife's watch, my iPad, my phone, and some other addresses that have been reserved as I've had some friends over in the last couple of days. Oh, and it looks like .139 is still on there. So this is the exact same thing. I always try to run this in Linux because it will show more than what a Windows box will show. But if you're just starting out and you only have access to Windows, then you only have access to Windows. Go ahead and run it. All right, with that, I'm going to pause this so we can show you how to make a network map. And presto, just like that, I have a new diagram. With this, I'm going to start maybe showing some things out. The first thing I want to do is I actually want to come down here to some images. And I like to do things a little bit differently. For instance, I'll take a Wi-Fi symbol here and I'll just make it super tiny so that I know what's connected via Wi-Fi. Everything else will be connected to a line. So this is Gliffy.com. If you've never seen this, you can go check it out. Feel free to use whatever package you want to use. I just use this for tutorials like this. All right, so let's pull up a box. We're going to call this box Fiber Modem. Really, this is, I should say, AT&T router. Now, it's not as big as that. It is as fat as that, though, and I will try to make it look like what it actually looks like. And it could have Wi-Fi if I turned it on. I've logged into this router and turned off the Wi-Fi because I don't want it competing with the Wi-Fi that I'm running. The next thing I'm going to do is I'm going to type in my router, which is an ASUS router. And this is where I will sit here and go, okay, it is a dual band with a backband channel. So what that means is that I can take this, and it has 3 antennas on it. Whoops. And I can connect. What does this tell me? Well, what this tells me is that my ASUS router, which sits literally right next to it, it actually does look like this on my shelf, without the boxes, of course. This is exactly the layout of this. So from here, I have another cable that goes off. Let me connect this. And sometimes there is an opportunity here to showcase like a cloud or the internet as a whole. And what I can just say is I can just draw a circle here. Whoops, no, I want a circle. We'll call this the internet. Let me clean this up a little bit. We'll throw this over. And this goes out to the internet. Now it actually goes out to a bunch of other stuff, but for all intents and purposes, you don't have any control over any of that, so call it the internet. So I know that if this is working and this is working and there's a problem with me connecting, it's somewhere over here, and I call up AT&T and I say blah, 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 do it. And then they do it. Otherwise, if the problem still persists and the AT&T router looks good, then I know the problem's on my end. And the problem's almost never on my end. Now, I have a Raspberry Pi. I love Raspberry Pis. If you've never played with one, you should totally consider spending the hard-earned cash it's going to take to make that happen. And I run the Pi-hole service off of my Raspberry Pi. And to showcase that I have the Pi-hole running, I will go to my address 10.0.1.34 Pi-hole, and we can see exactly how many things I've blocked and so forth. So this is my address, 10.0.1.34-admin is the Pi-hole administration. It even tells you the temperature and stuff of the Pi. It's fantastic. So then if I'm going to make a true network map, I'm going to write up some text. AT&T modem and router outbound connection. This may seem silly, but trust me when I say that silly is only a mindset. Let me clear these off, and what I really want to do is move this over and just say, hey, this is the outbound modem, ASUS router, and what I'll do here is I'll say, hey, whoops, that is not correct. Hold on. All right, I have my act together, I promise. What I'm going to say here is that the primary router, and it's going to start at 10.0.1.1, and that address is going to go to 10.0.1.254. And this tells me the network range of this router. Again, a lot of internal addresses are set up this way. I'm not telling you anything super secret about my setup. For here, I would say that this is the Raspberry Pi running Pi-hole. This is on 10.0.1.34 and functions as primary DNS, as we saw on the ARP request. Then from here, I might set up something like this computer. So this computer again is named after an old movie called Logan's Run, and this is Logan 6. I would copy this to let myself be known that this is connected via Wi-Fi. I might even turn it just for grins to know that it's connected via Wi-Fi. And here I would put down, since this is reserved, that I have an address here. For grins, I'm going to group these two things together so that I can move them as one unit. And I might have some other devices like laptops and phones that would be no different than Logan 6 in this regard. But this is a basic understanding of a network map. There's two reasons you want to make a network map. One, it just helps you understand your network and where things can break. Like, where are things falling apart? Two, in the untimely event of someone not making it through life, which happens sometimes, you're going to want to leave a map so that the next person coming in, or the next person to handle the network, or needs to know something about it or to fix it, understands what's going on and where. Otherwise, they have to do this whole process themselves. So if you are a budding network administrator you probably have access to a network map, or you're using software that will generate a map for you. If you are if you're someone who wants to learn how to do this, or you're about to take over a network, or you are the primary technical person in your household, understanding that accidents happen, people get hit by buses, and it's called a bus plan. You need a bus plan. And the bus plan is, I have a much more detailed network map should anybody need it upon my untimely death. It also helps to serve any of my clients that I've helped build a network for. If they come back and somebody, like for instance, there's a shop down the road, I did a network for them. They call me up 6 months after I set it up and said, hey, we're having a problem. Well, there's no way I'm going to remember that. So a network map allows me to quickly, easily, visually see what's going on with their network, so that I have a starting place to come back to. With that, I'm going to wrap this video up. Go find out about your network. How are things connected? What kind of cabling are they using? Are they using Wi-Fi? What kind of Wi-Fi are they using? And you can type all of that up into a network map. Doing this along with whatever study guide you have available to you is some serious hands-on experience, and I highly recommend everybody do it at least once. With that, I'll sign off. Sorry for the long video, but I figured this might save some time. All right, bye. See you in the next one.